Okay, we're going to be using problem number 12 from page 534 in chapter 10 to talk about different types of errors with hypothesis testing. The deal with hypothesis testing is we're basically saying that based on what I believe to be true about this sampling distribution, and if I was dealing with means, for example, if I thought the mean value was right in the center of that sampling distribution, I'm basically saying, hey, if I get something way over here, the probability of something being that far is so small that I'm going to reject my null hypothesis. Now, of course, there's always a chance, just by dumb luck, I could have gotten a single sample value, a single sample statistic, that really was that far away from my population parameter. But there's no way of knowing if, when I get a result out there, if that means that, you know what, if my assumption that this is so unlikely that that shouldn't occur is correct, or if I've just gotten a really odd sample that has given me results that would be very unlikely but yet could occur. So we're going to look at when you get it right and when you make errors. So one thing that can happen is you can, the null hypothesis, if it's true, you should fail to reject that null hypothesis. So that is a good thing if the null hypothesis is true and you fail to reject it. So that is a good thing. You kept something that wasn't true. If the null hypothesis was true and we did reject it, that is going to be a type 1 error. So this is a type 1 error, and the probability of making a type 1 error can be denoted with the letter alpha. That's the Greek letter alpha, and it can denote the probability of making a type 1 error. Now, the other thing I can do is I can fail to reject the null hypothesis when it's really false. In other words, it was really a false null hypothesis, but I kept it around anyway. That is a type 2 error. And the probability of making a type 2 error can be denoted with the letter beta. Now, the other thing that can happen is I can reject the null hypothesis when it really is false, and that's also a good thing. And this thing over here is also called the power of your test. The power of the test is the ability to reject the null hypothesis when it is actually false. Now we're going to go through and deal with this example in the context of this problem number 12. So in this case, my null hypothesis is that I have no cancer present, and the alternate hypothesis, if you can reject the hypothesis that there is no cancer, if you find cancer through this medical screening, then your alternate hypothesis is that cancer is present. So let's fill in context what these little boxes would mean. This box here would mean that you really did have no cancer, and you failed to reject it, so that would basically mean in context that you have no cancer, and the test says no cancer. So that is a very happy result. In the opposite corner, it's a less happy result, but at least it's an accurate result, that if the null hypothesis was false, that means you did have cancer. But the good news is, since I was rejecting my null hypothesis, the test did correctly indicate that I had cancer. So in this case, at least you know you have cancer and you can pursue appropriate treatment options. Now, and the other thing, if H0 is true, that means your null hypothesis is true. I have no cancer here, but unfortunately I rejected my null hypothesis, meaning that the test would suggest I did have cancer. And this would cause some problems because now I have additional stress in my life. They're going to do further medical testing, which is going to have expense, possible medical side effects involved in testing or treating cancer that you actually do not have. Now on this one up here, in this case, since the null hypothesis is false, you do have cancer, but your test results, since it failed to reject the null hypothesis, your test says it finds no evidence of cancer. This is, of course, very serious because if this cancer is progressing, you're going to have long-term health consequences because of this cancer growing that you are not receiving treatment for because the test results did not indicate its presence. So, now that we filled in this table in context, we can go through and answer the questions that ask you. So A asks about a false positive, in other words, thinking cancer is present when it is not. So we need to look at the part of our table where we do not have cancer, but we think cancer is positive, which would be this portion of the table down here. So that would be your false positive, and that in this case is a type 1 error. So a type 1 error in the context of this problem would be that you actually do not have cancer, but the test results suggest that cancer is present. A type 2 error in the context of this problem would be over here. It would be your false negative in this corner of your graph. It would be suggesting that you actually do have cancer present, but the test does not indicate the presence of cancer. Now, if you were looking at Part D, it's wanting to know what would happen if radiologists were less aggressive in following up on suspicious tests. Well, if you were less aggressive about labeling a test suspicious, you would be more likely to fail to reject your null hypothesis. So you would be spending more time in this row of the table, because if you were less aggressive, less suspicious about test results, you would be more likely to return a result that says, oh, there's no cancer here. Now, the problem with that, of course, is since we're spending more time up here, you're going to increase your number of type 2 errors, so you're going to have an increase in your number of tests that say that cancer is present. Test results that say no cancer is present when actually the person does have cancer. Now, as far as which one is more serious, a type 1 or type 2 error, that's going to depend in the context of the problem. For this one, I would think most people would say for the individual, the type 2 error is more significant because, of course, it's a bad thing to have a disease that you're not being treated for. But for the cost of medicine as a whole, the type 1 errors have an equal problem because they can cause delays in labs results getting in, and if you have a whole bunch of people who are receiving additional testing or treatments that they for follow-up that they did not need, that's an increasing healthcare cost for that individual and for insurance costs for society as a whole, and also it's backing up the lab services so that the people who actually do have cancer and need treatment can't get it because there's a backlog of people being screened and having further testing for cancer they did not actually have. So which is more serious, a type 1 or type 2 error? In this case, probably type 2, but it always depends on the context of the problem. There's always disadvantages to both types of errors.